Okie doke, ladies and gentlemen. Welcome to my talk. Today I'm going to talk about structured streaming 243. And the slides, if you are interested in seeing them again, I doubt that. But if you've got this urge to see them again, they are part of all the materials that I'm using for my Spark workshops. So under Unit 2, you should see this stateful stream processing now. You know, these are the slides I'm going to use for this talk. Okay? So when you go to my GitHub, just to show you that this is on my GitHub Jacek Laskowski. And once you are here, you see me here. So you are not mistaken. Just click Spark Workshop. Then you can scroll down, and there are, agenda slides, demo exercises, and among the slides, you can find all the slides. And under, stateful stream processing, you find the slides I'm using now. Okay? Good. So that's covered, and these are the slides. And to be honest, this is my first time I'm giving this talk. So you may guess that all the thoughts that are on these slides may change in the future, in the near future, because I'm still working on having full understanding of how Spark structured streaming works under the covers. So every day brings something new, and I'm working on these slides, even though they are already published, consider them work in progress, okay? Just like our software. So stateful stream processing. Stateful stream processing is, as it turned out, is a very huge topic. So, I was hoping to cover most of the areas that you can consider part of stateful stream processing in 45 minutes, but I already know that it's not possible. And you will see why in a moment, okay? But so don't get offended by description of this talk that I'm going to cover, all the internals of stateful stream processing. You will see enough. If not, ask questions and I'll fill you in, okay? Good. So we are at the latest and greatest Apache Spark, which is 243. They are working on 244. I saw some changes marked as 244. But the upcoming great release is coming, and it's going to be 300. Okay? I've got no idea what's coming for Spark structured streaming, to be honest, because I am fully focused on what's already available. There were moments in my life where I was, describing something that will be part of, upcoming version, and they eventually reverted the change because, it was not bulletproof or, ready for prime time. So I'm focusing on 243, which is the latest and greatest, and it's structured streaming. Okay, few words about me, but before that, I'm going to take a picture with me and you guys, okay? So I hope I'll see someone among the audience. Good, thank you. So I'm Jacek Laskowski. I'm a freelancer, and I'm working exclusively with Spark and Kafka, okay? And I'm using Scala as my favorite programming language. I'm not saying that this is the best programming language. It's just like one of the many languages supported by the environments I'm interested in, Spark and Kafka, okay? So I'm doing development. Despite my age, in Poland, they say that at my age, I should give up developing code because, if I did not program enough, probably it's not going to happen. But I still believe I can be a good coder, okay? So I'm still developing some software, and I'm publishing it to GitHub just to, show people how bad design, coding, and design I can, come up with. And I'm doing consulting and training. And still, even though all my work is public, people believe I can do something good for them, and they are paying me for this, which is good. You can follow me on Twitter, and you can find me at this email address. If you need some consultancy, development, or training, just drop me an email, and we can discuss, what I can do for you. I'm best known by these 5 Git books. They are at different levels of being, up to date with the latest and greatest versions of Kafka and Spark. Now, as you may have guessed, I'm focusing on Spark structured streaming, so you can see that. So you can find this Git book the most up to date. Recently, they released Kafka 2.3, and you can find that all these Kafka streams and Apache Kafka Gitbooks are not up to date because of the recent release. It was 2 days ago, if I'm not mistaken. Anyway, it's free of charge, and you don't have to pay for reading what I already know about Kafka and Spark. So the only difference between having me here on stage or live, when I'm giving workshops or running workshops or doing development, is that you can ask questions or something that would trigger some of my thinking that would contribute to what you may eventually find in these Gitbooks. Okay, good. You can find me on Stack Overflow. To my surprise, I'm the top one among the top answers for Spark Structured Streaming. Yeah, to my surprise. And I'm finally the third at the top Apache Spark answers. That was my dream. So now, finally, I've got my score. Good. Okay, so this is my, so that was about me. That was the intro. I hope you haven't decided yet to leave this place, and you will not, because this is the agenda I'm going to cover today. And as you can see, we've got 7 items to cover with, demos for each. So you can easily conclude that 45 minutes won't be enough. And yeah, definitely, it's going to be too much, too little. So if you've got any questions, any specific questions, and you see that time is running up, let me know. Just raise your hand, and we can discuss what you are interested in rather than what I'm focusing on. Okay, good. So structured streaming, stateful stream processing, aggregation, watermark, join. Then we focus a little bit on something I promised to cover, yet looks like it's number 6, and you see that we won't have much time on it. Arbitrary stateful streaming aggregation. It's like this. I started exploring, the source code, and I started taking notes, and eventually it turned out that all my description that I gave for this talk was like describing, what happens under the covers in Spark Structured Streaming. So, I would have to spend, hours rather than minutes. So I apologize in advance for lack of, in-depth content if that happens. And then the last but not least, state stores, which was something I found quite interesting. I didn't know that you can read, that Spark Structured Streaming saves all the streaming state in files on HDFS or on HDFS compliant file system, and you can read it back without Spark. You can change, some state if you need to. That's possible. Okay. So I'm sharing it because I know that very little information is available on this topic. Okay, good. So structured streaming, what is this? Well, it's just streaming data sets, streaming queries. So whenever you say structured query, it's not obvious whether you are speaking about Spark SQL or structured streaming. But if you say streaming queries, that's obvious that you are speaking about Apache Spark's module called Spark Structured Streaming, okay? But under the covers, the difference between structured streaming queries and structured queries in general is almost non-existent, meaning that Spark Structured Streaming, also known, or something I call Spark streams, just to refer to Flink and Kafka and Akka streams or streaming solutions. So Spark streams, it uses streaming queries which are nothing else but Spark SQL's queries with some features that this module needs to give you this sense of streaming processing, okay? So in other words, you can consider, but you'd be mistaken, it's the complete understanding of Spark Structured Streaming. You could consider structured streaming as if you executed batch queries every batch interval, okay? They call it batch interval. for micro batches, but there is this brand new module called continuous execution that gives only one batch, and it's being continuously executed. Okay, so I'm not going to cover it, but just know that it's similar, but not exactly the definition you should be using for structured streaming. Know that streaming queries are executed by Spark SQL engine, so all you know about Spark SQL is easily transferable to Spark structured streaming. So all the optimizations, query plans, logical and physical query plans, this execution pipeline, it's very similar, if not exactly the same. Okay? There are some differences because we are speaking about something that's continuously executed or being executed rather than one-time streaming query, structured query, like in Spark SQL. The beauty of Spark structured streaming compared to Spark SQL to Spark SQL is that you are expressing your queries using the very same language you are using for Spark SQL, for expressing your queries using this declarative high-level language. It's called Dataset API for programmers like you, or SQL for not daily programmers, if I may put it this way, like you, okay? So it means that you can mix and match your queries using Dataset API or expressed using Dataset API or SQL, okay? So regardless of the language you are using to express your streaming query, they'll internally be the same, okay? So there is no performance penalty choosing between Dataset API or SQL. It's like you prefer SQL over Dataset API, and that's it, okay? It's just your personal preference. Internally, they'll be the same, or they are supposed to be the same, or they are supposed to give you the same query plans. Good. So you've got this logical and physical query plans with operators, and now streaming operators, and they are all based on this Spark SQL infrastructure. Okay? Good. What's different in structured streaming compared to Spark SQL is that structured streaming supports something that you can consider streaming state. Okay? It's saved on HDFS-like or compliant file system in files that you can query later, something similar that you can find in Kafka Streams if you've ever used with this framework. Okay? So you've got support for stateful operators, and the stateful operators give you this notion of windowed aggregations, streaming joins, and other streaming goodies. Any questions? Awesome. So, stateful stream processing, what is this? Okay? A couple of days ago, it was 2 weeks ago, when I was closer to giving this talk, and the closer, the more frustrated of having not enough information I was. So, I asked this question: is stateful stream processing equivalent to streaming aggregation? To my surprise, Jay from Confluent answered almost immediately, no. And now I finally understood that he was right, even though my first reaction when I was tweeted about my concerns and doubts was, well, why not? Now I know that besides streaming aggregation, we also have streaming deduplication. We've got streaming join, which is something we'll be using fairly often in Spark structured streaming, and something I didn't know that I haven't found in other frameworks: streaming limit. I don't know whether this streaming limit, the name exists in stateful stream processing literature or area, but that just nicely match other streaming something. Okay. So we've got this streaming limit. That's something that I found while preparing myself for this talk. It was like, oh, that's interesting. Okay, so but I'm not gonna cover it. I'm just making sure that you heard this streaming limit with Spark Structured Streaming, and if you need to know more, what are the use cases or how to use it, just let me know after my talk. Good. But know that streaming query is stateful when it uses state. And state can be implicit. You can know that you are dealing with that you are dealing with some state, but you've got no access to the state. Or explicit, when you've got direct access to the state you are operating on. Okay, so except your live stream data, you have also direct access to the state that's associated, using this notion that they use in Kafka Streams, associated with this particular operator. Okay? By the way, just to give you some differences between Kafka Streams and Spark Structured Streaming, Spark Structured Streaming operates on 0, 1, or many rows at a time, while in Kafka Streams, and probably in Flink too, operator has access to only one and exactly one record at a time. It's a huge difference between these solutions, not to say frameworks, because Kafka Streams is not a framework. But anyway, going back to Spark Structured Streaming. So we've got this stateful stream processing. So now, knowing that these terms like stream aggregation, stream limit, deduplication, join, now we are asking ourselves, okay, we know the theory, but how to express stateful streaming using all the operators that are available in Spark Structured Streaming? And the answer is, whenever you use groupBy, rollup, yes, that was kind of surprising to me that rollup and cube are supported. I was sure a couple of days ago that they were not, but I checked and they are. GroupBy key, drop duplicates, join, and limit. If you use these operators with streaming dataset, in other words, this dataset that you created is streaming, you will immediately fire up all the machinery, underlying machinery for state management. So you are immediately working with some notion of state. Good. So you've got this query, and like in Spark SQL, any structured query, including streaming queries, which are, by definition, structured queries. The full name is structured streaming queries, if you want to use it. They become logical plan. They become logical plans. So that's the reason why I borrowed this naming convention from Kafka Streams, that all the operators we programmers use are high level. I haven't found it in official documentation of Spark where they say high level operators. Why they are high level? Because compared to logical query plans, all these operators that build that constitute something that you could consider logical query plan, they are very low level. You usually not create your queries using these operators. So these high-level declarative operators, they are declarative because you say what you want to do, not how they operate. You hope that the operation is exactly to your liking. They create something that you call unanalyzed logical plan. Okay? And it's only after analyzer does a job, you can consider your query complete and workable or executable. Okay? So just to have this conversation with you and my slides. So let me rephrase what I said previously when I said something that started with, in structured streaming, a streaming query is stateful when it uses the following logical operators. So in other words, whenever you are responsible for performance tuning and you've got access to no code because you shouldn't be bothered with the source code because you'd spend days trying to figure out what this code is doing before you do your real work. So you look at logical plans, and whenever you see state store restore or state store save physical operators, you know that you are dealing with some state. This query is stateful. You may also be interested in streaming the duplicate exec, flat map groups, streaming symmetric, hash join, streaming global. And I'm pretty sure that you can easily guess what these logical operators stand for what high-level operators they, what they represent. So, for example, the duplicate, you know that this is for drop duplicates. Flat map groups is for something for arbitrary stateful streaming operators. This is very advanced operator. So if you see this in your query plans, it's like, oh man, this team is, is using the heaviest machinery for stream processing available in Spark Success Streaming. Be careful. And this is for joins, streaming joins, and this is for this limit, streaming limits I'm not going to cover today. But just know that whenever you see this operators, you are dealing with stateful streaming processing in Spark Success Streaming. So what is streaming aggregation, or what's streaming aggregation in Spark Success Streaming? So whenever you use groupBy, rollup, cube, or groupBy key, you are working or you are creating streaming query that's streaming aggregation. Okay? So you create streaming aggregation. You are aggregating over an unbounded stream of data. So now you might be asking yourself about, how is it possible that I've got access to something that was available, a year ago in my stream? Well, you need this or you don't. These are the questions you should be asking yourself because, keeping state forever will eventually lead to out-of-memory errors, right? So this is another concept I'm going to cover in a moment. But just think about state is something that you have available for your processing, but the state somehow, at some point, has to disappear, has to time out, so you can, get this memory, the disk, and and memory back for other data that's coming, rather than keeping it forever. But anyway, so you've got this groupBy, rollup, cube, and groupBy key. So these are operators that all create something that you will see in query plans as aggregate logical operator. So you are not interested in the gory details of the code you are optimizing, except that you know that this aggregate logical operator may have been the reason or may have been part of this query plan you are optimizing because of one of the operators. Okay? So again, I'm telling you this because in my consulting days, whenever I'm asked to optimize some queries, people say, you want to see code, but it's written in Python and you are a Scala developer, so you might have some troubles understanding what we've been up to. And I say, I don't care what language you are using, SQL, Python, or Java or Scala. I'm interested in query plans. Give me query plans. And that's what confuses my customers, because they are not familiar with query plans because, well, they are most of the time they are programmers or data scientists. So they don't care about this low-level bits and bytes. That's why they are calling me, which is fine, and that's the reason why they are paying me for the time we have this nice conversation. The longer the better, all the consultants know it. But eventually, I need to provide some guidance how to optimize queries. So I say, hey, are you doing groupBy? Yes, we are doing it. I haven't said you are using Python or Scala. I don't care about it. You are using aggregation, right? Right. What's your, something I'm going to cover in a moment. What's your, something like this, something like that's covered on this slide. What's your window function? How did you define your window function? Is it wide enough, or is it short enough to meet your requirements. So I have this conversation even though I saw no line of the code these people wrote. Because I'm looking at something that's generated by this code, regardless of the programming language. And that's the beauty of working with Spark. You can look at different things and still have this nice conversation. Paid conversation. So, OK. So, streaming aggregation, so demo. How much time? So it was 25, some half through the talk. OK, so let me show you something. OK, so it's not that I'm talking and no code is shown, is presented. So this is the demo that's part of my book. It's free of charge. You don't have to pay for this. So yeah, we are discussing, how much money to pay for this or for that. This is free of charge. OK, you will pay later. If you've got some questions, you will come. OK, and I'll remember that you didn't pay previously. So we start with this. OK. So num shuffle partitions. Some people, if you've ever worked with Spark SQL or Spark Success Streaming, you know that there is this notion of default level of parallelism, number of tasks, and all the low-level bits and bytes that there are tasks, and tasks are in one-to-one relationship with partitions. Only partitions have data. As a matter of fact, no, partitions have no data because it's only logical term. It becomes eventually task, and task query for data, so no data is touched unless you start tasks. So, but going back to this, shuffle partitions. In Spark Success Streaming and in Spark SQL, you've got by default 200 partitions. Why? I asked this question a few times, and the answer is we've got we did some tests, and by doing tests, we just figured that 200 is good enough in most cases. And that's the explanation, OK? There are other places where 200 is used, and no one can prove this is the best number for your query. That's why you need to think about number of shuffle partitions for operations like groupBy. Because number of partitions immediately says how many state stores you are using for your data, OK? And state stores are the stores, key value stores for your data. So the less, the bigger the size of your state stores, which may or may not be something you want. So I change it to 1. Why is that? Because then I've got only one task for my query, and I can easily look at the single file for my one single partition, and just see all the data I'm sending. And since it's a demo, I'm under control in this controlled environment, I can easily say how many state stores I'm going to deal with just one. But this is not very performant. Well, for demo, it's as performant as I wanted. OK, so this is just this trick to change the number of partitions, one of the many. So this is what you need to know about creating Spark Success Streaming query. So you see, you've got this Spark session, and you read stream rather than read. And other than the read stream, all the other lines are exactly what you could have written or you may have written for Spark SQL query, for batch query. So that's the only change. See? But the beauty of this is that you can always ask for schema, be it in Spark SQL or Spark Success Streaming. OK, that's easy. So you created data set using dataset API. You could have used SQL. Eventually, you ended up with data frame. So I just took these lines, I exploded it, and split, exploded it, blah, blah, blah. I just did some transformation. We don't necessarily care about what exactly is happening in this code, because eventually we are interested in this query plan that's created by this code. And as you may have guessed, depending on your level of expertise in Spark, you may have written something like this, Some other people could write exactly the same line using some other, development techniques, coding techniques, but eventually, we all would end up with the same query plan. That's why looking at query plan gives you the best information you need while dealing with performance issues. Because you are not looking at this code. Let's pretend it's a code, okay? It was written by me. I hope it is. And you can read it and you can understand what it does. So you do groupBy. You do groupBy on something that's streaming, so you do streaming aggregation, and you are counting all the occurrences of word across, now the question is, across what? Across one round of processing, or all the rounds that happen under the covers? Well, that's the question that I'm going to answer in a moment, because that depends on trigger you are using. Spark structured streaming, at least in 2.4.3, supports 2 execution modes. And one execution mode is micro-batch, the one that was available since the very beginning, and something very new and modern, continuous execution. Okay? The difference is how many rounds you will have, and then this question about how many words I've got for each round may or may not have bigger meaning or bigger. Might be more important than if we used continuous execution. Okay, so running counts, you checkpoint location. This is very important. It's part of my slides, so don't worry. Even though I change slides to this code, I'm covering something that's part of my slides. So checkpoint location, why is it important? Well, this is where Spark Structured Streaming saves current state. And I'm not only talking about state, your state, business state, but also about processing state. Something like, what offset from Kafka this query already processed. Something that you may or may not control directly, but Spark needs to know it, so it guarantees that only that the data is processed exactly once. Okay? So these guarantees are given by and you are using them, and that's the reason why you are using Spark Structured Stream, probably, too. So in checkpoint location, you can find all the files, yes, files, kind of like database. In Kafka Streams, they are using RockDB for some state. Here, they are files. So files work fine, or worked fine for Spark SQL, so they leverage this knowledge. So they are using this checkpoint location to save all the information in files, sometimes in JSON format, so you can just cut this file and see what happens with your query. Sometimes in a compressed format. So you have to use some external tools or just write code to decompress and see what's saved in this file, compressed file. The beauty of this checkpoint location is that with all the tools, with all the knowledge you may have after this talk or soon after speaking to me, you can change the state of your query, stop your query, change the state, and rerun your query with modified state, which is nice. It's like hacking something that should run continuously, but you know that bad things may happen, so you may need to change the state if you saved something that you shouldn't have. So you can change this checkpoint location, and keeping this checkpoint location in proper format, you can rerun your query, and this query would notice no change. That's possible. Okay, so I delete this checkpoint location just from previous execution, just for me, because some data sources do not support being restarted from checkpoint location, like memory, and I'm using memory here. So that's why I wrote this code. I appreciate if you could come up with something more clever than this. And I'm using complete output mode because, well, I'm just outputting count as records come in, okay? So as I mentioned, this output mode is here, complete, And you see something I did mention, but it's not part of this code, trigger. So trigger is how often a batch should execute. Not how long, but how often. So the shorter the trigger, the often the batches are executed, and the more frequent batches. So now the question is, how a particular batch knows, what was already processed. This is exactly what checkpoint location is for. So if you start it afresh, there is no checkpoint location, there is no state, so it knows that it should start from the very beginning, while if there is some state saved, it will restart from the place was processed back then, okay? So that's why I specify checkpoint location. Okay, and other than that, it's pure Spark structured streaming query. But we know, by looking at explain, so I'm saying, hey, Spark, explain itself, okay? So, hey, query, explain itself. So this physical plan, look at this, uses data source v2. It's a brand new API for modern data sources in recent versions of Spark structured streaming, v2. And you see hash aggregate. That's okay. That tells you that this is aggregation. But this operator tells you, we are dealing with state, some notion of state. And by looking at this, you know that the keys are words. And state information gives you more information like checkpoint location, like file. You see, this is the checkpoint location I used to start the query. And other information that you may or may not need to fine-tune your query. Okay? And by the way, just before your certification, Spark certification, what does this star stand for? What is this? It's not my mistake trying to, using italic or bold letters. It's like, so I may have forgotten something like this. No. It's to say that for this particular piece of query plan, Spark auto-generated Java-based code. So rather than being interpreted operator at a time, Spark tries to grab as much query as possible and generate code for this without you even knowing about it. And it happens all the time. And you cannot disable it, even though there are some switches that you could try, but they won't work. So all the stars are good signs that this code is as performant as possible. And as you can see, there are 2, 3, 4, 5. Well, some operators do not support, code generation. That's why you see all the, different numbers. Good. Any questions? No questions? So look at this. By looking at this query, you can easily figure out what the streaming query looked like. You are scanning over socket. Nice. Then you project, because you need to have this value only. You may have used select for this. Then you explode. You see it here. Then you group by. That's exactly our query. So you are reading your query from bottom to the top, and you can easily decompose this query plan into working code. You can regenerate. So if you forget committing your code on Friday and you need it on Monday, something bad happened over weekend, you can just look at the query plan of your queries that are running on production and try to come up with try to come up with the code that stands for this execution plan. That's easy. Okay, and so you can just work with this, and this is just entire code. You can just run it, and it's fine. Okay, nothing really crazy. But at some point, you need to ask this question: how long to keep state, because eventually we run out of memory, run out of disk space. Because, well, if there are files that keep all the state that was available back then, you will eventually run out of disk space. Not to mention that you won't have that much memory to process, the state with all the new records. Tell me, what's the worst case for groupBy? What's specific about input data where groupBy will suffer a lot? No. What's that? Data skew? No. It's even worse. And think algorithmically rather than in Spark way. When all the data use unique keys. So if you've got, for every record, you've got unique key, your file with interim state will keep growing, right? Because it will keep, keeping state for every record, which is unique key. So you can imagine that if you've got thousands of records, eventually you will have thousands of entries in this file, which is exactly what you want to avoid. And that's the reason why you hoped groupBy would avoid, because you try to create groups. But these groups are all unique, are all one single row based. So so this is where you've got this streaming watermark. Eventually you say, we need no data, we need data only for 5 minutes. So you say, apply watermark to my state and expire it after 5 minutes based on event time. So now the question is, what's the event time? And how can I control event time? Well, by definition, when I say event time, it means time that comes with events. So events can convey time they were generated at, whatever it meant at the time they were generated. This time comes with events, and based on this time, you can say, by using with watermark high-level operator, you can say what column is time-based and gives you this notion of time. So, and there is this delay. So you can say when exactly to expire your state. Okay? So rather than keeping state forever, you will say there is this trigger, there is this time, this threshold, after which the state that's old, considered old, will disappear. This is state. But also this watermark is for something that they call late events. Events are out of order, and they may be late. For example, we are late because I'm now talking and talking, so we should be finishing up now. But okay, let's pretend we are late event. Okay. So, and by the way, we are late event because this is the last event today, right? Yeah. Okay, so we are late event. Oh, nice. Okay, you are so smart, yes. Okay, so think of it. You are in elevator, and you are playing your game. Okay? And this elevator, you are so obsessed with this game that you forget that you should leave your elevator, and you keep in this cave, okay, or cage. So you play in this cage, so you've got no connectivity with your backend. So backend receives no data. So if this data is needed to build something that you could consider as state of this user, which is usually called session, you need to start monitoring events from this particular user. And these events come with timestamp. But you are in this cage in elevator, so you are sending no events. And now the question is, are you still playing? And in this particular example, yes, we are still playing in elevator, or you just gave up because you died, for example. Or you just disappeared somehow, okay? So eventually, you, backend developer, query developer, have to decide whether to finish this session or not. And this is where watermark comes onto stage, where it says, 5 minutes elapsed since the last time we heard from this user, so we consider this state closed, and we can just get rid of it. Okay? And just to finish it off with this nice example, just very quickly, you know this trick to limit number of state stores, timestamp, and blah, blah, blah. This is the code that, OK, so let me show you this. We are using memory stream data source. Why am I using memory stream? Because I can control what's being emitted. By using this memory stream, I can just add values I want, and they appear in my stream. This is very nice for user testing, demo, and blah, blah, blah. So I created values, which is data set. OK, don't worry about how data is coming in. Just know that values is an unbounded stream of data. And you say, hey, on this unbounded stream of values, I want to apply watermark on column called time with this delay threshold of 10 seconds. What is threshold? It says, even though events are 5 minutes later, based on time, we will wait 10 seconds more until we close this group, this session. OK? And then output something to the output. So this explain will show you event time watermark, this operator that says explicitly that with watermark was used. So again, looking at a query plan, it's exactly as if you looked at the code you may have written or some other people. But you don't care about whether it's written in Python, Scala, Java, or blah, 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 because, well, you see all you needed to fine-tune your query. And then window duration, because you group by. This is another boundary you apply to your data. And, well, and that's pretty much it. Because when you do counts per 5-sec window and you explain it, well, do I have it here? Yes, I have it here. You see state store save. And you see event time watermark. What is this telling you? It's telling you that you are dealing with state, but this state is time-bound because of this. How is it time-bound? On timestamp. So you should send something with this timestamp column. An interval for delay is 10 seconds. Now the question is, what's the current watermark? But this is, topic of another talk, perhaps next year. Thanks for having me next year in advance. So we may discuss it in more details. Part 2 is coming. You have to wait a little bit longer than in your favorite season, favorite movie. So just by looking at your query plan, you can just say exactly what you need about the query that someone else wrote using, his or her favorite language.